All right, hello and welcome to Pulumi TV. My name is David Flanagan, although hopefully you know me from across the internet as Raw Code. Today we're going to be taking a look at the contributor experience, which means we're going to show you how to get involved with the Pulumi projects. And today we're taking a look at pulumi-kubernetes. And I'm joined by two wonderful colleagues of mine, Levi and Vivek. Hey guys, how's it going?
Good. How are you?
Yeah, I do good. I do this in, like every stream I've done for 2 years. I've said, "Hey, how are you?" And I throw it at more than one person, and then you got to see who answers first. Why don't we start with you, Levi? Can you tell us a little bit about you, and then we'll move around.
Sure. So I'm Levi. I've been at Pulumi, I guess, a little over 3.5 years now, and I've been the primary maintainer of the Kubernetes provider for most of that time.
Thank you very much.
Yeah, and I'll go real quick. So my name is Vivek. I work with Levi on a bunch of our native providers, of which Kubernetes is one. I've been helping out with the Kubernetes provider for the last roughly year or so. I've been at the company for about 2. Yeah, and happy to be here.
All right. Well, thank you both for joining me. I think the best way for today's session is just to get my screen shared right away, and then we could talk about the layout of the Kubernetes provider and try and give people a little bit of insight in how they can get involved. I know that it's one of those repositories that can feel a little bit intimidating to new people, and we want to kind of break those walls down today and show people how they can get started with this project. So here we have the README. I guess the goodest place is any to start. We also, where's my activity bar? Big deal. I'll open it in this mode. There we go. And we have the file system here. So where do you want to start then? Do you want to go over the directory structure of this project? Is there a convenient place to start that most people find maybe a little bit confusing upfront?
I was actually wondering, maybe Levi, if you wanted to, just talk very briefly, go over the history of the Kubernetes provider, because that I think will also have some implications in terms of how it's structured and how it may look different from other providers that we support. So if you want to just walk through that, since you're a little closer to that history, that'd be great.
Yeah, that makes sense. So our Kubernetes provider is one of the oldest providers that Pulumi has done. It was our first, what we're calling native providers. This was around prior to Pulumi Schema and the registry and the multi-language everything. So this was originally all written in TypeScript. So this one looks a little bit different from our other providers just because that predated everything else, and it's been brought up to like use the schema and the code gen and be more similar to our other providers, but it's definitely the most complicated one, and you'll see a number of things that are kind of from that legacy there, just because it did predate a lot of these other tools. So for the most part, the directory structure should look similar to what you would see in the other native providers. Like you see your SDK folder and your provider folder, and then the make file. So that all is fairly similar there, but some of the things we're doing with it are a little more sophisticated than our other providers. The goal is eventually to bring this more in line with the way we're doing it everywhere. But this is a great way to kind of go through how it is now and figure out how to get it to an easier place to contribute.
Yeah, there's definitely some commonality that I see here that maybe we could just touch on really briefly. But most of the Pulumi providers, I think it's fair to say, they have like a little bit of Go code that kind of does all the gluey stuff, and then that lives inside of the provider folder. And then there's an SDK folder which then has the SDKs for all of the different languages that are supported by Pulumi. I think that's almost ubiquitous. Is that a fair assumption?
That is right, and for all of our native providers, the SDK folder, everything that lives in there is code generated. The provider is the actual implementation for like all the client stuff and how it's actually talking to the cloud and talking back to the Pulumi engine. And then there's also a bunch of code that handles mapping all the resources into the Pulumi schema so that we can run our code generation on that.
All right. So
yeah, exactly.
Yeah.
No, sorry. I guess like one of the common misconceptions that people have is like, they try to like they find something wrong with the docs or rather like with one of our SDKs, and they try to fix it by making a change directly into the SDK directory somewhere. And unfortunately, that's often like one of the first things that we can't quite take on directly, because all of those things are automatically generated. In fact, most of the files that you'll see will have a preamble saying that this was automatically generated.
Okay, so I want to make sure I understood that correctly. Everything inside the SDK is generated. Yes.
Right. So if you make a change there, next time the build is run, it will override any changes that you've made to that file. So if you want to make a fix, you have to actually make it in the part that's generating the code.
Yeah, I can see why that would be a little bit challenging to someone that's not aware of that, coming to the repository, what appears to be a really trivial fix, and they can find it in the SDKs and go, oh, I fixed it, but really it's not done in a way that's going to be actually fixing the problem for future users. Right. All right, so when people come to this project, then they should spend, if they want to make a change or improvement, they spend all of their time inside of the provider folder. Is that correct? Okay.
That's right.
Yep. So is this where the code gen happens? I guess we got the commands here and we've got the package. So there's quite a lot going on there. Maybe we could give kind of a quick overview of what's going on inside the provider.
Sure. So looking in the package folder, you'll see the provider directory. That one is going to be common to all of our native providers, and that has the provider.go file there. And if you open that up, that has the implementation for all of the gRPC methods that we use to talk to the engine. So you'll have this file in every single one of the providers. So this is setting up like all of the credentials, reading in like the configuration for the provider, setting up the connection to the Kubernetes cluster. And then you've got like the CRUD methods, create, read, updates, deletes, and then a number of other methods as well.
Does the predictability, I don't know if that's the right word, of the Kubernetes API make it a lot easier to code gen this SDK because everything is kind of defined up front regardless of resource? Is that a fair assumption?
It is fairly straightforward in Kubernetes because it does use that standard CRUD model. Some of the providers are a little more challenging to map to that, but all of our native providers use that same model. So in some cases, the trick is figuring out how you map the upstream API to this model.
Got it. Okay, cool. So they get this provider. I mean, I'm assuming from my superficial 4.5 seconds of looking at this file that most people come into this project probably don't need to end up in here, or is that incorrect?
That's right. If you were writing your own native provider, you would be working in a file like this, but for most contributors to the Kubernetes provider specifically, this wouldn't be something you'd have to worry about.
All right, excellent. So they've got the provider, though. I guess a lot of this other stuff is how it speaks to the Kubernetes API, loads the config, I'm assuming, from this.
Right. Yeah, so most of what this in this folder is for talking to the API, and then we've also got implementation for some of our overlays, which include Helm and YAML support and Customize. I think all of those are features that are somewhat unique to the Kubernetes provider, where it's support for common tools that people already use for managing Kubernetes, and it's built on top of the core provider.
Okay, cool. So could we try understand how the code gen on this provider works, so that people have an idea? When they're coming along, I'm assuming that regenerating the SDKs would be a very common thing they have to do as part of their debug and test loop. Like, what does that look like?
Yeah, so if you go up to the package directory, there's a folder called gen, and that is where all of our code generation code lives. So something that's kind of unique to the Kubernetes provider, we've got those overlays that I just mentioned, and those are specific to each SDK. So we've got those template folders. You see one for each one of the languages. There's the Go templates, .NET templates, Node.js, and Python templates. So if you needed to make a fix to the overlays specifically, that's a little bit different workflow there.
Well, could we take a step back for a moment? And what do we mean by overlay in the context of this provider?
Actually, that's a good point.
Maybe if I can just like kind of walk through the actual, like the overall flow. So there's actually in the provider, there's like the CMD directory. You'll see that actually has the has two binaries. So if you go to provider CMD, you'll see actually there should be the CRD to Pulumi as well, but we'll ignore that for now. So we have Pulumi Gen Kubernetes and Pulumi Resource Kubernetes. Pulumi Gen Kubernetes is the binary that's focused on the schema generation. So in this grand scheme of things, when it comes to Pulumi sort of provider ecosystem, we create this like schema, which is basically a JSON schema specification of what the resources are, what the the relevant properties are, any parameters necessary for like language SDK generation and things like that. Like a lot of that stuff is encoded into this like JSON, like schema JSON. In fact, you'll see that in the Pulumi Resource Kubernetes directory, you'll see a schema JSON file there, which is the current latest schema for this particular provider. So that's the thing that, like the code generation, essentially, there's a few different steps in this pipeline. So first thing is to generate a schema JSON. And then using that schema JSON, you can essentially create the corresponding language SDKs, right? So a lot of what's going on initially is like Pulumi Gen Kubernetes runs and it generates essentially a schema JSON, which is then consumed again by Gen Kubernetes to create the SDKs that you see in the SDK directory. The Pulumi Gen Kubernetes obviously really only has like a simple main Go. It does most of its stuff in the Pulumi, like the PKG Gen package, which is what Levi was pointing to earlier. If you wanted to trace that sort of code base, you'd probably want to start from main.go and like go through that entire sort of flow. But essentially, we are the end goal is to generate a schema JSON. What's going on is actually, in Pulumi Gen Kubernetes, we are taking the open API specification from Kubernetes, and we're generating the corresponding, resources and types and things like that into the schema JSON. In addition to what's in the default open API specification, we also have these overlays, which are like additional resources that we have custom developed, essentially, if you want to think of it. So there is the Helm chart, there's the YAML config file, there is the customize. I'm forgetting something, I'm sure, but basically there's these additional resources that we have created they're basically component resources, and they were actually implemented on an individual language level. This is a little bit of history for those people who are deeply familiar with how Pulumi works currently. Like, component resources we support on a bunch of different languages, and you can use them or consume them from within the same language. It's only recently that we've added the support for multi-line components. So a lot of this support predates multi-line components. But essentially, Helm chart and a few other of these kind of resources are kind of hand implemented in each one of the languages. So if you look at the PKG Gen templates folders, you'll see the corresponding sort of implementations for these component resources in each of these, each of these languages.
Okay, I'm going to try and repeat that back to you and tell me what I get wrong.
Right.
Right.
Sorry, that was pretty dense. I apologize.
No, but that's great, right? That's what we want these sessions to be. We want to be able to kind of really understand these things in a way that just we haven't done before. But people will find this useful, and hopefully it can encourage more people to contribute and help to the project. So inside of the provider folder, we've got a couple of commands. We're ignoring CRD to Pulumi for now, but we have pulumi-gen Kubernetes and pulumi resource Kubernetes. Now, I've seen this naming structure across a lot of our providers. It's pretty common to have a pulumi-gen and a pulumi resource within our provider. So that makes sense. But the job of the pulumi-gen Kubernetes here is purely to generate the schema.json. And what you said was we do that by pulling the open API specification from each Kubernetes release and generating what kind of like JSON schema, but had a quite, is it small Pulumi flavor to it in some way as far as structure goes. And it's these schema.json I think we use across all of our providers to then generate all of the SDKs. So that I think I got a good handle on. Now from here, we are generating all of the SDKs from that, and that's fine. But we have this concept of an overlay. Now, when you first said overlay, I thought maybe we were augmenting the resources that we'd already generated. But it sounds like we're actually just adding on new convenience resources instead for the Kubernetes provider. So in our core Kubernetes support, we support custom resources, Helm, customize the YAML config, and I'll ignore path.ts because I don't know what that is. So these are ways that we are enriching the Kubernetes support beyond the open API specifications. So in my head, that feels like a really good way for people to get involved in the project, is to bring maybe more of these overlays to increase certain support within Kubernetes. Is that correct? Anything I get there wrong? Anything you want to fix?
So the thing that's tricky about overlays is they have to be implemented for each language. So it was initially just TypeScript, and then we had TypeScript and Python, and now that we're up to, I guess, six different languages. It's difficult to actually get language parity here. So we're thinking about ways that we can make that so there's not as much manually written code like that. So generally, like I would say that is a useful way to contribute, but the tricky part is that it's 6 different languages you have to work across now.
Yeah, I can imagine that. Quite tricky.
Yeah, and one of the challenges, so you know, we're actively thinking about how we want to support this on an ongoing basis. Certainly, like the existing component resources we have, we continue to support and manage. We hit an interesting sort of decision point recently when we added the Helm release resource, for example. We actually implemented it as a custom resource within the provider. So basically leveraging the SDK, CodeGen, and all of these things to make it work across all the different languages. But like the provider internally implements the actual Helm release sort of aspect. We got away with that a little bit because, you know, Helm is a Go sort of project, and we could embed that into the provider. Essentially, like we could go a fair way. If you wanted to do things that are like somewhat language specific, then you know, and which are not Go essentially because that provider is written in Go, then you get into an interesting decision point. Certainly now that we have multi-line components and other things, it's increasingly interesting to kind of see these things implemented as multi-line components, and whether or not that needs to live within the Kubernetes provider repository is like another question. Like these components can live independently, and in often cases that might be a better model than explicitly shipping it as part of the Kubernetes provider.
I would say though, for an external contributor who is interested in something like that, that's definitely an interesting conversation to have, but that would be something to engage like the Pulumi engineers with before going a long way down the road of trying to put together a pull request.
Yeah.
I guess the best way for people to do that would just be to open an issue on the repository and start a conversation, or I mean, even use the Kubernetes channel in our community Slack, right?
Precisely.
Yeah, that'd be a great place.
We also have a contributors or something channel as well on the Slack channel. Like either is fine. Issue or like start with the enhancement request or whatever on the Kubernetes GitHub repository. We're happy to engage there, or do it on Slack if you want like more interactive conversations over this.
Okay, here's a tough question for you both. So, you maintain pulumi-kubernetes, and besides Kubernetes releases and pulling in changes to the schema, etc. Like, where is most of the maintenance or time spent with this provider? Like, what do you feel that you're working on 90% of your time? If that's I don't know if it's just bugs, is it new features? If it's most of it's generated, like, how can people get involved, and what parts of that can we kind of point them to?
Yeah, I would say there's probably three main categories there. So the first one is the overlays that we talked about. Those were a lot of work to get to a stable point. At this point, I think they're overall working pretty well, but Helm, the Helm chart in particular, was a lot of work to try to get to a good state. The second category is we call it await logic internally to the provider. You can also think of that as readiness logic. So when you have created a Kubernetes resource, we have some custom logic here to determine when it's ready. And the reason why that is useful in a Pulumi update model is, say, if you've created an ingress or a service and possibly your cloud provider is provisioning a load balancer, you want to make sure that that's ready and you have an IP address or a URL that you can hit with other resources that might depend on it. So typically when you were applying Kubernetes resources, if you were using kubectl, for example, you would send all that over to the cluster, but you wouldn't necessarily know when it was ready. So if you've got other components downstream of that depend on that, you need some way of checking to see if it's ready. So that's another big section. That's a fairly interesting topic if you want to go into that more in a moment. And then I guess the third category briefly is just all of the examples that we've got. So certain cloud providers have kind of a central place where you can pull examples from. That's true to some extent in Kubernetes through the upstream API docs. So we would like to make it easier to contribute examples back, but right now, basically those are hand generated as well and get injected into the schema. So if you've got more questions on any of those areas, I'm happy to go into more detail.
Just to add,
Sorry,
to what Levi said, another, like, obviously, as far as what we spend our time on is concerned, like certainly the categories that like Levi mentioned make a lot of sense. We obviously have new features and new concepts that we want to add. We've done that, for example, with Helm release and other things. Certainly, there's a lot of complexities around, again, we're kind of automatically converting given an API specification, to the underlying schema and things like that. There's certainly often, you would run into, not often, but sometimes you run into some sort of a mismatch in terms of like how we handling certain things. So for example, recently we ran into issues with like config maps are immutable or not, like how do we handle them? Like, those kind of behavioral kind of things that is more sort of business logic and something that we understand as Kubernetes users, and we need to like layer that into the provider. Those are some of the things that we often step in on and like, hey, like this did not translate exactly verbatim from like the API specification, maybe because it's lacking or like there's additional interpretation that needs to happen there. We kind of interject there and help out sort of that transition. In general, that's often where we spend a fair amount of our time on in terms of just smoothing out the experience for our users. And await logic is a great example of like that, kind of users 90% of the time or 99% of the time, it works exactly the way we want to desire, but like every now and then they run into some sort of an exception to the rule, and we need to understand that better and like layer that on.
All right, awesome, thank you. So I think I had two things in my head there. One, you mentioned that the examples live inside the schema.json. Is that correct? Or did I misunderstand that?
Yes, that gets injected as part of the code generation into the schema.json. Let's see. I have to remember
So
where that lives.
specifically, when we talk about examples, it gets a little bit ambiguous. Like there's obviously the examples of like a full-blown Kubernetes program, like like Pulumi program that does with like deals with Kubernetes resources and things like that. Like those, at least in this repository, we have in a test directory, we run like end-to-end tests, integration tests against those here and there for the various languages and so on. We also have the Pulumi examples repository, which is obviously our central location where we track like different use cases for different resources, and that's often where we would point users to. That's like our de facto location where we would ask people who are considering adopting Pulumi to go look for inspiration. The examples that we're talking about here are more like in our API doc. So if you were to pull up our, and things like that. So if you were to pull up our SDK either on an, like in VS Code or like any other IDE, or if you were to go take a look at our API docs on our website and so on and so forth, often you'll see some examples there about like, hey, how do I create a deployment? How do I create a config map? How do I create blah, blah, blah using the Pulumi SDK in the various languages? That's the part that gets injected into the schema JSON as well. And then we can render that appropriately in the various language SDKs.
So if you want to actually look at the code for that, that's in the package gen examples folder. And there's two different kinds here. So we've got the overlays, which are documentation for like Helm and YAML and customize. And then we've got the upstream one, and these are just the vanilla resources here. So these are our markdown files that get rendered into the API docs for each language.
Cool. All right.
So this would actually be a great place for external contributions, because I think this is straightforward to understand the scope, and it's just a markdown file. So you could add examples to like for any resource like this.
So people could come to this repository, go to upstream inside examples directory, just add a markdown file with more Kubernetes resources, and the next time that gets merged into our code base, it will end up on our registry page as the API docs examples for Pulumi Kubernetes. Awesome. That's a really cool way for people to get involved, actually, without having to dive into all the provider, the codegen and stuff like that, because there are a lot of Kubernetes resources, and giving our users more access to examples, I think, is a very valuable thing. So yeah, definitely encouraging that. We have a question from Marcus in the chat, and he's just asking, like, are we generating our SDK against vanilla upstream Kubernetes, and he's curious about support for like EKS, which has additional AWS resources. So we have any advice there for Marcus?
Yeah, this is the vanilla Kubernetes schema. So each release of Kubernetes includes an open API spec. That's another JSON file. So we've got code that parses that and translates that into the Pulumi schema. And we have a separate EKS component, EKS provider that manages some of those AWS resources specifically, but the Kubernetes provider is just vanilla Kubernetes plus those overlays that we talked about.
Yeah, I think the Kubernetes provider, like just for those people who are new to Pulumi and so on, so the Kubernetes provider is specifically meant for manipulating and managing Kubernetes resources in a cluster, or essentially, so you're creating things like deployments and Helm, like for example, Helm charts, installing them, managing them, and so on and so forth. It's like setting up a setting up a Kubernetes cluster is typically done in a different provider. So you have like the EKS provider that will do the EKS provisioning. We have Google Google Native and Google GCP provider for managing, for example, GKE, AWS, and Azure, and so on and so forth. So there's a little bit of distinction in terms of, basically, if you think about a provider, it's like, what is the backing sort of cloud environment that it's managing. In the case of the Kubernetes provider, it is talking to the Kubernetes API spec, and we basically track the latest release of the API spec at all times with the provider.
Yeah, that's another interesting point about the Kubernetes provider is this can be used with any cluster. It could be like a cloud managed cluster like you just talked about, or you could be running Kind or Docker Desktop, or like whatever other flavor of Kubernetes you happen to be running. So you can configure the provider to point at that and develop it locally as well.
Awesome. All right. So I think we've kind of covered the code base and a few areas where people can get involved. Now, I'm curious if we're feeling brave. And I was going to say we'll go off script, but we've always been off script. So, like, assuming someone comes across, right, and they've found an issue on the GitHub tracker, and they're like, okay, I want to kind of take a go at this, and they make some changes to their code. Could we maybe walk through the process of, like, how do they build a provider? Like, what are there make targets that they should be familiar with? Is there just go build? Is it that easy? Like, what do people need to know from that perspective?
So we're actually in the process of standardizing this across all of the native providers right now. So I think a month from now, this will be more consistent across Pulumi, but it is all driven through the Makefile. So I believe the README should have instructions for any prerequisites that you need to have installed. And then there's just a couple of make targets that you'd have to run.
So we do have a contributing file as well. That's probably a better starting point for, especially if you're going to look at trying to contribute to it's very short. There's not a lot to it, but basically, there's some dependencies that you need. So making sure would typically, this is a pattern that we use across Pulumi. This is something that you'll see in a lot of Pulumi repositories. You typically run something like making sure to make sure that you have the appropriate versions of things. This is mostly really just doing go download, like go mod download type equivalent, essentially, in this repository. Repositories that are a little bit more complex and have external dependencies. And then in this repository, really just a make build and a make install gets you ready to kind of play around with your local version of the provider. So it's relatively
build include,
because it's fairly standard.
Does that make build include fetching the latest Kubernetes schema? Yeah,
it does. Yep.
All right. So I mean,
so actually, if you look at the Makefile,
yeah, sure.
Sorry. Yeah, so we can actually walk through how we generate the SD, or like what version you're tracking. So in the Makefile, you'll see basically a reference to cube version, so capital all caps cube _ version. So currently it's set to track v1.24.0, which is like the latest and greatest sort of major version, at least for the API specification. And essentially, anytime you do a make build here, it's going to basically go fetch that particular Open API spec, a version of the Open API spec, and go through the whole code generation process, make the provider, make the SDK, all of those things locally for you.
Okay, I actually see we even have an Open API file target, which I assume is just going to pull down that Swagger Open API definition. Okay, cool. Another thing, just because I was on the top of the contributing, and I get this question all the time, and people are asking, like, if I'm going to build a provider, do I need all of the supported languages and runtimes on my machine? I think, is it fair to say the ideal answer would be yes, if you want to build all the SDKs, but also you really only need the runtime for the SDK that you want to work with locally. Is that a fair assumption? Yes, I see you nodding.
If you're running the build and install target, that assumes that you have all of them. There are specific targets if you're wanting to just develop in a particular language as well.
Okay, and if someone were to submit a pull request, but they'd only built the TypeScript SDK, is that a problem? Is that something that CI generates and commits back, or is that something that you as a maintainer would then have to then fresh push to their pull request? Like, if they want to submit a pull request, do they need them all? Is that what we encourage?
It would depend on exactly what they were touching. CI would run all of the SDKs, so if it ended up being a change that needed them all, that would be caught. But there would be certain types of changes where you wouldn't necessarily need them all.
Okay.
Yeah, often one of the challenges, like it'd be maybe worthwhile for us to, for example, make a silly change to like one of the examples, for example, or whatever, you know, and because in theory, I believe that should translate down to all the SDKs and so on and so forth as well when you make the actual generation. But essentially, you know, one of the problems that often happens is like you do it and then you only check in partial some of the generated code. Like we do check in all the code into the SDK folder. That's again like consistent behavior across all our providers. There's a lot of people who both within the team and outside that like have problems with that model of operation, but there's good reasons to do it, partly because of the way Go works and so on, like especially for our Go SDK. We're not going to debate that decision here, but basically, you know, so we do check, for example, like CI will warn if it notices like basically the equivalent of Git porcelain kind of functionality, where we'll notice that like there's local changes that haven't been committed to the repository and things like that. So there's a few gotchas there when it comes to you know, dealing with generated code essentially, but certainly things that we are happy to walk contributors through if they run into it, and definitely things that we can improve in terms of documentation. So obviously, like any other place, like if you run into issues, like the simplest pull request would be an improvement to like the contributing guide, which can definitely use a lot more attention. We would love to get more relevant feedback from people that are not us, you know, to make that process a lot more documented and well maintained, but certainly have people within the team also focusing on that effort a little bit more, as Levi mentioned. But yeah, hopefully that gives you a general sense of like how basic contributions can work.
Yeah, I think so. Okay, I'm going to pick a couple of these targets that I think are useful. Schema calls k8gen, so we'll call that, and that's just going to take our Open API specification and generate our Pulumi schema, right? The schema.json. Okay. So we'll let that do its thing. And then we have the ability to build the provider. So this is going to give us the Go binary that we could put in our path. I guess this is the pulumi-resource-kubernetes.
Exactly.
Is that right?
Right.
Yeah. Were you going to say something there, Levi?
No, that's just right.
All right. Okay. So yeah, like, so I'm in my head, I'm thinking, okay, if I'm working on this and I want to be able to test this with like a really simple Pulumi program that I have, I really just need to run make Kate's provider, which maybe we can do. And then if I just put that into my Go path, I should be able to run a Pulumi up and actually use the version of the provider that I have built, which is
exactly
awesome.
Exactly.
And then from there we have, and I see that's the standard across a lot of our providers. I think this is really valuable information to people that maybe haven't delved into that side of Pulumi yet, but we always seem to have this .NET underscore SDK or SDK underscore .NET value that we can build. So I'm not going to build .NET because I don't model. I don't think it works on an M1 Mac yet. We can build the Node.js SDK. I think that would probably be the only targets I need, right? From there, I can use Pulumi, TypeScript SDK, my new provider, and I'm working with whatever build I have local in my machine.
Right.
Yeah,
awesome.
There's one of the things that you might want to do is the install targets. Like there's install targets for the SDKs. So for example, there should be an install target for Node.js, for example, which will basically do a yarn link type thing for you. So then if you had an example that you were working with and you had, for example, SDK changes that you wanted to use, you could like yarn link locally against that like locally generated Kubernetes SDK, and then use that. Similarly, there's similar mechanisms for the different languages. They're slightly different in their behavior, but essentially that's what we use.
Yeah, and as Levi mentioned earlier, if people like one of the ways people can contribute would be maybe with our await logic, and using the yarn link here would allow them to kind of consume that pretty quickly and test it. So, yeah, that's a pretty.
The nice thing about the nice thing about like some of the await logic and stuff like that is a lot of that is baked into the provider. So like if you have the provider built in like in your path, then you're all good, right? And that just goes from there. Sometimes like there is a little like this two-phase problem where like you have the provider change and you might have like SDK changes as well, and like you may get into why isn't this most likely you'll run it at compile time. Like you run into like, hey, like this new property that I was hoping for is not showing up in my example. Oh, that's because you're probably not running against the current version of the SDK or whatever. Like, so there's a little bit of a mental model to understand that you might have. Is the shape matching what you're, are you actually using the right SDK to match the shape that you wanted, basically?
Okay, awesome. Yeah, good to call that out. Like there is that two-phase kind of commit. You can be working with the provider itself, and you only have to build the provider and stick it in your path. But if you're making any overlay changes or schema changes, then that would require the SDK to be updated as well. So yeah, good to call that out. All right, now the hardest question for last then. So, do you ever run the tests locally, or do you explicitly rely on CI? And if you do run it locally, what is it make test, or is there something else they could be running locally?
Yeah, so I have not actually run the test with the make target in a long time. That's CI that kicks that all off because it's interacting with the cloud for the most part. I do often run the examples locally. Like we've got examples for each language, so I'll run that as part of testing a specific stack, but it's not through the make target necessarily.
So actually, this is an area that we can use some contributions on or discussions on. Like one of the things, like we do set up for, as Levi said, set up like a cloud managed Kubernetes environment. So this by default is like a GKE environment in CI, and that we run all our tests against. You can certainly point it to any old cluster, but there are some tests, for example, that rely on ingress or load balancer behavior, which again gets all wonky when you're trying to do like hind or whatever. So there's certainly a class of like vast majority of the tests will work fine locally, and frankly, like as long as you just have like a kubeconfig locally that works correctly, like your if you were to just run the make tests, most of them would just work. There are certain which will fail, and that's most likely because they require some, like a load balancer kind of support or what have you. We would like one of the things that we were just recently talking about is like maybe putting them behind a build target or whatever, so that it's a little bit more easier for users to know like what is safe to run locally and what is not, essentially, and like what to expect, basically. Some of our tests are actually smart about it. Like they will determine if you're running against like the cloud or not, and like kind of automatically skip them and things like that. But that's not uniform across the board. But certainly an area we're more than happy to chat about to make it more easy for people to run. I do run some tests locally, but they're it definitely improved. Like that should be improved quite a bit going forward.
Okay. Now, someone coming along who is wanting to make their first contribution, then, like normally we'd say, yeah, always write a test. But with a lot of this being code gen, is it safe to say that maybe tests wouldn't be needed for most first-time contributors to the project?
Often, what I've done is like we have a pretty good provider test framework, actually. If you take a look at it, it's not like the degree of effort to prove that your thing works locally on like say this is you'll see it in the test directory, and then SDK, Node.js, or whatever. If you were to pick any of these examples, they basically should look like any old Pulumi program for the most bit. So this is like just this is what you would run locally often, right? To validate that this thing works. And then there's often a corresponding entry in a Go test file, which will basically run this test. So if you wanted to pull up, sorry, my screen share is not working here.
Node.js test.go in that same Node.js folder.
It should be at the bottom.
Okay.
Yeah, there you go. So here, for example, if you were to look at our, this is, for example, a test where it's basically saying, this is a little bit more complicated. We could probably look at a much simpler test if you go a little bit further down. Probably just start with that. This is obviously more complex. Towards the bottom, I would imagine you would see some relatively simple tests.
Replace daemon set? Is that simple?
Sure. Let's go with that, right? So basically, you're saying, hey, like run the test in like the directory thing says, hey, run the test against replace daemon set step 1. So that's like the first. Like you could, for example, test out things like you want to do, an initial deployment and then an update to it, and then so on and so forth. So the way we've typically done that is like have multiple directories underneath. So you'll have like replace daemon set step 1, which will actually have like your baseline code for your actual Pulumi program. And then there would be a step 2, for example, that would be a very specific change, right? And then you can assert the behavior is matching that kind of change, right? Similarly, you can add extra runtime validation. All of this is like optional. You don't have to do it, but like basically you can prove that, these things are working correctly. So like going from a example that works locally to a full addition to the integration test suite is actually relatively straightforward, but often something that we can like walk people through during a PR, or we could follow up with after the fact. So we don't necessarily block on that. It's often a lot easier to just have this conversation.
All right, awesome. Well, we are coming up on 50 minutes. So I'm not going to throw any more difficult questions.
Did we just end?
I'm not sure if we lost David here.
I think we might have lost David. Great. So we're now the official host of this. I guess long story short, I think really think there's a bunch of room for additional improvements to our sort of contributor experience. But I think we always welcome the opportunity to talk to the community and like get valuable and like sort of shepherd changes to do. We would love to see more contributions from the community. We'd love to also obviously make sure that we meet you halfway in terms of providing you the tools and resources you need to make this easier. So certainly keep us to that bar, and this is something we care pretty deeply about on the team. And hopefully, the experience gets easier and easier as we go.
Yeah, I agree with all that.
We just like took over as hosts for like 5 minutes.
Yeah, I went to turn off my screen share, and then I think my router or my Wi-Fi I had to switch to Tether. So I'm really sorry about that. I don't know what happened. No, but I was just going to say, I think we've covered an awful lot in 50 minutes here, and I hope that people find this useful. We'll definitely do more sessions in the future. Maybe we'll even work on a wee bug fix or a feature at some point live and have a bit of fun there. But I just want to say thank you both for joining us today. It was really great to just get some of that knowledge out of your heads and share that with people. And I hope that people feel less intimidated by some of these code gen repositories and feel that they can come and talk to us and make contributions and get involved in the project. So.
Awesome. No, I really appreciate this. This was great. I think we got a lot of things that we had in the back of our mind and we've discussed on the course of PRs and things like that. But getting that context out in a reusable format in this way is really helpful. And hopefully that just means that we will continue to make this easier and easier for users to start contributing that.
All right. Well, I'll let you both get back to your day. Thank you again. I will speak to you both soon. And to everyone watching, have a great day. Thanks all.
Thank you.
Bye.